turned in. Be welcome, be seated, be well. So, as you might have heard before, we're going to talk about Qt on microcontrollers, which is a super hot topic. So you have wearables, everything from vital electronic devices, fun gadgets. It's all getting smaller and smaller, and the software you develop your applications with plays a massively important role in how your applications will perform on low-end processors and low-memory devices. Now, here with me to talk about this, you've heard him before, is Santtu Ahonen. He is our product manager for everything around embedded devices. He's based in our Helsinki office, and yeah, whenever I try to do a Finnish accent around the office, Santtu is kind of my blueprint to do so. So without further ado, Santtu, please tell us about Qt on microcontrollers.
Yeah, hello, good morning, good evening. Patrick, I don't think your Finnish accent is very convincing, but mine should be.
Will you let me try?
No, we'll go on with the thing. So today, and now I have something to do with the, let's see if I can change the slide. Yes, going to be talking about the mega trends in the market, and they touch some of the things we are already offering out of the box with Qt, so things you can do with the current Qt. And then going to be covering our approach with the microcontrollers, with the super low hardware, and then talk about the services and how we can make this thing happen for you. So I'm going to jump to the bigger phases. So bigger phases mean displays and UIs, and these displays are entering our life, our professional and personal private life from left and right, and that's because the cost of displays and the cost of mini computers being able to run and show stuff on the displays is actually getting low enough, or even lower than building traditional hardware interfaces with hardware buttons and sliders and screens. So the trend is that anything that used to be earlier sliders and hardware buttons is now turning into software and touch UI. And user expectation for these touch UIs is actually driven by mobile phones. So mobile phones are actually quite performant. They are the response times and the speed and the capabilities are pretty high. And then people are using their coffee machines or their 3D printers or whatever other systems where these touch interfaces are. Their expectation for the performance is on that smartphone level, which is really tough for us doing the software for the embedded development and with the gravity of getting the bill of material down. And then this also means that the software industry has been entered by a lot of people and a lot of businesses, markets that are traditional hardware houses and who have not been using and doing software before. So even though doing a button on a screen and then moving that to a different place and adding another button is much cheaper than doing that on the hardware layer, especially if you have to do it after you already shipped the product. There is a lot of old competencies, processes and practices with these companies that may not apply to creating software. So a concrete example is that in some industries, they have 100 years of tradition on how to source and optimize the manufacturing of hardware components from subcontractors and subcontractors for subcontractors and so on. But then when they're trying to do the same with the software, that they try to source different parts of source code from one supplier and then have another one compile it and third one deploying it, it's going horribly wrong. So some of the old practices and processes really cannot be used in the software business. So there's also quite a bit of learning and things happening in that space too. What we also see, and why we are now talking about the MCUs, is that the traditional Cortex-A world has been scaling down to ever more power consumption efficiency and to smaller and cheaper bill of material, but at the same time what used to be the MCU world of the monochrome LCD displays is actually now growing up. So scaling to the upper end of the MCU devices where there is already quarter wide video screens and full colors and quite a lot of memory and so on. So these two worlds are now colliding and meeting each other in the middle. And that's also a reason why we are, from the Qt side, is looking into the MCU side of stuff. And having said that, I think the Cortex-A should not be news for anybody, but the Cortex-A world is very well supported and covered by the Qt through a number of different operating systems. But the new thing is really going into the Cortex-M. Another thing that is changing and trending in the market is that the number of these devices, as I said, the bigger faces are everywhere, and the software interfaces and to run different machines and operate different systems is coming all over. So the number of different systems is growing to billions and trillions of devices, and the forecasts for different chipset vendors are super positive in how this market will grow. The challenge on the whole industry is that we cannot grow developers fast enough. So it's a similar situation as in the schools. Everybody is taught to read and write, but very few become actually authors of books or editors for magazines. It's a similar situation with software development. So even though in the universities today, basically everybody is taught the basics of programming and how to program, very few people actually become programmers. So the industry needs to come up with solutions and ways to be able to make the scarce or developers that we have on the business more productive. And the solution to that is tools and frameworks, and that's exactly where Qt is sitting. So we see the future in the world and the support of different environments super positive from our point of view. And also, if you are a developer there listening, I think your forecast for the future is also super. So that was the sort of the intro to the mega trends and things happening on the market. So now going into what do we already have when you install the QtWS18? What do we already have out of the box? So we do have a very good support for different kinds of hardware. So the high-end hardwares where these PCs and IMX8s and Tegra X2s and other alikes, many of the Renaissance Aircar platforms are sitting. We do have a very good support of the mid-range hardware, and on the low end of the Cortex-A with the IMX7, IMX6 based boards. We have pre-built support for getting started for many of those, and then you can compile Qt into almost any platform that has just basic interfaces underneath available and a reasonably new compiler available. And the Qt key values here are that you write it once and you deploy everywhere. And we really want to stick to that because that is really important for our embedded developers being able to develop on one platform. And then when they get their proto hardware out, they can deploy on that proto hardware and they can get their implementation and deployment working on from day one of their project. We do have this feature or this concept that we have been promoting in, if you have been reading the Qt blogs, which is the Qt Lite. The Qt Lite for us is a concept and a project that we use as a name when we are talking about making Qt modular and fitting into the smaller devices. So by that definition, the MCU work also is falling under the Qt Lite work. And the big things on the Qt Lite on the Cortex-A side and on the 5 from 5.6 onwards is that we have really improved the way you compile and create the binaries, being able to compress and make smaller binaries and faster binaries. So the footprints have been reducing a lot in 5.9, so up to 60% smaller footprints. And then the new thing we have now done in the 5.12. Which is an LTS release released at the end of last year. is that we have now improved also the support on how to use the Qt Lite configurations and Qt Lite configurator tool in context with Yocto-based embedded Linux projects. So it's made even easier to make smaller footprint binaries, and which also means faster for the embedded devices. And this is a path and part of the concept and work we are going to be using also going towards the MCUs. So those are the sort of highlights of what do we support out of the box with Qt. So now looking into the MCUs. So microcontrollers, when I'm talking about the microcontrollers, I'm talking about specifically Cortex-M4 and Cortex-M7. So those are the higher end of the MCUs. And for now, we are not looking to support the Cortex-M0, Cortex-M1, or Cortex-M3. But obviously, we are studying those. But currently, we are looking into the Cortex-M4 and Cortex-M7. And then to sort of put them in the map with all the other Cortex ARM generations, the Cortex-A's are already supported by Qt quite well. So as I said, this is the old stuff for us. So on the MCUs, the operating system is defining quite a lot of what we can support on the Qt applications. So we know that we can do bare metal Qt on MCU. We have that running on STM32F7 and NXP1050. But if we do bare metal, we only can support display at this stage, and then it's going to be a static monolith delivery into the device. So anytime you deliver or you flash the device with a new version of your application, you deliver everything into the device. We can also support FreeRTOS. FreeRTOS as a vanilla FreeRTOS is going to be in the same level of feature support as we see with the bare metal. So we can support the display, and then there is an Amazon-created POSIX libraries available for FreeRTOS. So if we add those, we can support the threads, and we can also add the support for touch networking, audio, video file system into that. But those are additional custom work, and we'll work with those with the customer when that is needed. And then we have picked the RT-EMS as our preferred operating system for the MCU, under which we can support all these features of threads, display, touch, networking, audio, video, file system, and a lot more out of the box with RT-EMS. And we can also support this kind of a static monolith, but also shared build delivery into the device, which makes the implementation part much easier and faster when you are in the development phase. If you look into the Qt features that are likely to be supported on the MCU, so we know that we have applications running on the QWidget UI. We have QML with limitations. So depending on what kind of application you are running and what is the target level for frames per second, but there are some functions of QML that are really heavy, like for example shaders. So if you don't have a GPU in your MCU and you want to reach 20 FPS, the shaders are out of the question. So there are things like that that are impacting that. We know that we can support the internationalization, the text inputs, text rendering, virtual keyboards, TrueType fonts, the basic TCP/IP connectivity. What we are currently working on is to make sure the developer workflow. So how do we integrate this into the creator, and how do you deploy and debug and profile your application in the MCU? So that's all under work. What we are also studying is that those MCUs where there is a GPU available, can we actually utilize the true 3D modeling in those devices? And that's because typically the GPUs on MCUs are really optimized on accelerating 2D graphics, but not true 3D graphics. So that's something we are studying. Is there something we can do? And then obviously there will be limitations set by the hardware and operating system. So the hardware will set some limitations on the capabilities like if there are totally missing hardware interfaces, or there is just pure physics and the gravity of software development. So if the hardware is not capable of certain performance, so you really, fixing that on software is super difficult. But obviously you can always fake it, so then there are tricks how to go around those. Then if you look at the memory consumptions on the MCU, so the MCU, the cases typically are really sensitive to the bill of material and to the total cost of the building the devices. So, and the memory is one of the expensive bits on building the devices. So the memory has a big impact for our MCU customers. In the MCU world, we talk about the internal memories, which are the microprocessor internal memories, typically from 300 kilobytes to 2 megabytes, and then external are SDRAM memories that are purchased in chunks of 8 megabytes. So those are 8, 16, 32 that typically are on the MCU devices. And then the frame buffer, so the UI that you are running and the display and the color depth has impact into the amount of memory spent. So the more colors and the bigger screen you're running, the more you need frame buffers. And if you are running graphical acceleration, typically you need a couple of frame buffers, one which you are building and the other one which you are throwing to the display. So that has an impact into the total memory budgets on those devices. But currently, when we are building the QWidget UI-based demo applications, we are running on SDRAM of 3.4 megabytes. So we do need the external SDRAM and ROM up to 6.6 megabytes. And when we have been deploying and playing with the QML-based e-bike demo application or with the wearable application, what you saw the images on the previous slides, the SDRAM consumption is currently between 8 and 10 megabytes. And we know we can squeeze that by stripping features below 8 if required. And then on the ROM side, we are spending currently 13 megabytes. So these are the current limits of the memory. And I think, as we work along with the customers and we create the project with the customer, we will get better at this, because we know there are areas where we can and help in the memory. So, and that leads me to the discussion about the professional services. So the MCUs at this stage is a professional service activity. And if you look at the customer project, which is building a device, and this goes for all the embedded devices. So the different colors on this picture represent different vendors for different technologies. So the real projects out there need to deal with different hardware vendors and different components and different software elements and put those all together, usually on their own. So and making this environment, if you are not using Qt, is often underestimated the complexity. So getting the evaluation package running on the board is still fairly easy, but then setting up the host environment to deploy to the board and get your first application run on board, and then enable the debugging, profiling from host to the target board is getting really difficult. And then this whole table turns around into quite complex when you are doing custom hardware, which results that you need a custom BSP and OS adaptation and so on. So this is often what we see, that customers have been underestimating, and then they turn to us and could they use Qt and really benefit from the Qt for being a cross-platform environment and getting over several of these hurdles. And for that purpose, we do have the Boot2Qt environments that are a great starting point for software development. And really the Boot2Qt is there to get the deployment starting from day one of the project. So when you get the Qt license, you have the pre-built images for many of the most common target devices, and you can get your software development going. But this really is a starting point as a project. So the Boot2Qt is there, great for the prototyping, concepting, and getting started. But the downside of the Boot2Qt is that being a great starting point for development is also means that it enables pretty much anything you can imagine that you would need enabled in your project. And then for the actual production, it's quite big and quite cumbersome. So what you want to do during the project is go into customizing the operating system, customizing the Qt elements, and building your own images. And that's the other side of the story. So we do have a very good offering available for developers to build their own Qt and build their own environment. And if you are shy, you don't know how to do it, then we have a very good expertise and services to do it for you. And that leads to the other part is that, especially with the MCU environments, currently we are delivering the environment with the host development environment and with the software image for development on the device as a service based on the customer needs. And obviously, we can do this for any other environment also. So we can do this on the Cortex-A devices if you need that kind of help, and we see that often customers do need it. But this is especially what we do with the Qt on MCU. And the other reason we do that on is that the Qt alone is a huge environment. It has a lot of different modules and technologies. Some of which are really not relevant on the MCU environment, like Qt Max extras or Android extras, or that kind of stuff. So those are obviously not relevant for the MCU. But then there are some things that we know that we cannot support, at least for time being, on the MCU environment. Then there are things that we know that we can support, but enabling all of them at the same time for the development maybe doesn't make sense, because that makes the footprint and the performance not what you want to have in your environment. And then there are certain elements that we know that we can support, but maybe not fully. So there may be some limitations, and we need to then discuss with the customer project on which of these things you really need, and then enable those. And a big part now in the early stages with the MCU project is that doing this customization of the Qt itself and building this modularity for the needs of the customer project on the MCU is something that is part of the project we will do with the customer. So if you look at the life cycle of the project and the schedules, so typically what we want to do is we want to join at the concept creation and prototype creation phase to do a prototype UI as a service for the customer on MCU. And then while we do it, that helps us in scoping the work for the implementation. So, for example, which of the Qt modules from the previous slide are really needed, where if the customer is planning that they want to use shadings, we may look into the desired bill of material and hardware and come up with some alternative solutions on how to use those. Also, for the internationalization or TrueType fonts, there are some tricks and ways to pre-render those so that you can save memory and so on. And all of that is part of the project and the implementation support we want to do with the customer. But it really starts with the joining on doing the proto together for the first customers on Qt on MCU. I think that concludes the actual presentation side. We are ready to go. We're ready to get your project started with us on MCU. And I'd be eager to hear and learn all the different products that you guys are planning and working on. So where can we help with that? And I think that's that for today.
Well, thank you, Santtu. I think you deserved one of those. Great stuff. Yeah, exciting. Okay, very well. Let's take some questions. Can you say something? Because I think you're...
something.
Yes, excellent. So we have a couple of questions that are around, are you going to support X platform, which I'm going to fast fire at you. Are you ready? I'll take this as a yes.
I didn't capture the question.
Right. Are you going to support the following platform? Kale RTX.
No, we haven't looked into that. We'd like to hear your needs in more detail. So I'd advise, let's get in touch and look into that. We typically can support fairly easy environments that have a POSIX layer, and it needs to be fairly complete POSIX layer. But as I said, we can go all the way to the bare metal. So it's a question of effort and what you actually want to achieve. So
some also went specifically into the effort associated with porting to free RTOS and POSIX. Maybe you want to elaborate a bit on that.
Yeah, so the effort needed depends on the features. So again, what products you are building. So if you need threading or you need, for example, networking, those are adding to the features. So the POSIX library available for Amazon is actually very limited set of POSIX features. And then for us to support the free RTOS with all the possible features that you may need, it means that the remaining POSIX bit needs to be ported on top of the POSIX library available for free RTOS. And this is then a dialogue with you guys, because I can't give you an exact number of hours that it will take. It totally depends on the features and the product you want to build. And then we can help in scoping that. So that's also why we would like to get into this dialogue and discussion with you, and then do the prototype with you, and then come up with the understanding that what's missing and what really needs to be done. There may be also other ways of doing it, but it depends on the case.
Here we have, is Qt for embedded OSs such as Integrity or QNX maintained by the Qt company, RTOS vendors, or third-party contributors?
We do a big part of the maintenance on the Integrity and QNX, but obviously we are working very closely with Integrity and QNX and a few other vendors of operating systems. So we do get fixes and contributions also from those vendors. If you want the exact statistics, you go to the Merit and knock yourself out.
Someone asked how they can get Qt builds for STM32F7, or how they can port it to that platform. Where can I download it?
You can get the builds by entering a project with us. So let's have that discussion and understand what you want to do and what's your product, and then we can start building the environment for you.
Do you consider ESP32 SoC for Qt for embedded?
We haven't looked into that, the ESP32 SoC, but if you really need that, I'd like to understand your business case. Qt is a very flexible framework, so supporting different environments obviously can be done by third parties, and there are third parties doing that, but we are also looking into supporting those. But if it's something which is needed by one customer only, it's typically a service, or it's in the early infancy and adoption. We do this first as a service before we take them as part of the main release content, which is something for everybody.
All right, we have STM Micros MCU does not write on support MCUs. Can you support it, for example, in ST32F7?
Yes, STM32F7 and STM32F4 is we have both a proof of concept and a Qt running on those, so we can demonstrate that. And if you're joining the embedded world, you will see the Qt applications running on those hardware, and also on the NXP1050.
All right, seems like we have time for one more. So I have one written down from earlier. I want to download and try this. How can I do it?
For now, you cannot. So as I said, we are doing this as a service and a project for customers. And when we've done enough of customers and we know how we can productize it so that it could be a general support, then we'll make that available. But for now, we are working on the customer project, and that means that if you are a customer taking the MCU from us, you get also because you have our full attention on making it working and making a product that we can then sell to other customers later on.
All right, excellent. Now we have to move along. Thank you very much, Santtu, for this presentation.
You're welcome.
And